Welcome to the video on Design of Tall Buildings. In this video, you will learn about the structural elements and load transfer mechanisms in a framed structure, and the considerations in structural design of buildings. The loads on a building are of two types depending on their direction: gravity load and lateral load. Gravity load acts in the direction of the gravitational pull, which is downwards, whereas the lateral loads act perpendicular to the gravity loads, as shown. These loads acting on the building need to be resisted adequately to have a strong and stable structure. As a solution, structural engineers have designed and developed the concept of efficient load transfer through the different structural elements for both the load directions. Nowadays, we adapt framed structures for constructing buildings, as the weight is transferred efficiently through the network of beams and columns in the frame. In the framed structure, the load from each floor is transferred through the adjacent frame members into the foundation below. So, what are the main structural elements in a building frame structure? The elements that participate in the load transfer mechanism, that is, the load-bearing structures, are the following. The beams resist loads applied perpendicular to their axis. The columns transmit the loads downwards through axial compression. The slabs carry the floor loads and transfer them to the beams. And finally, the footings in the foundation transmit the loads carried from the building superstructure to the soil below. The non-load-bearing elements are as follows. Cladding or walls are placed around the building with a purpose to cover it. These claddings or walls do not participate in load transfer in case of framed structures. As a structural engineer, your job is to make these structural elements strong enough to resist the loads on the building, and hence, prevent the building or its elements from failure. Let us take a look at the load transfer for both the loading directions using these structural elements. You have two load transfer paths: gravity load path and lateral load path. The load path can be identified by two parameters. 1. The elements in the building that contribute to load resistance. And 2. By observing how they transmit the load to the next element. Note that the foundations of a building act as the ultimate load bearers. Therefore, any load path is designated to transfer the loads from the areas subjected to loads to the foundations. So, load paths have a combination of vertical and horizontal load-bearing members. Now, the gravity load path is for the transfer of loads acting in the direction of gravity, like dead loads and live loads due to human occupancy, snow, etc. The vertical gravity load acts on a slab, which transfers the load to the beams, which in turn transfer the load to the columns, and then down to the foundations. The lateral load path is for the transfer of loads acting sideways, like wind loads and earthquake loads. The primary vertical members bearing the lateral loads are shear walls and frames, whereas the horizontal elements are roof and floor slabs and foundations. Note that, in framed structures, shear walls, unlike partition walls, are load-bearing walls, which receive lateral forces from slabs and transmit them to the foundations. Roof and floor systems take horizontal forces from the stories that are above their level and transfer them to shear walls or frames in the story immediately below, which in turn transfer the load to the foundations. Shear walls receive lateral forces from slabs and transmit them to the foundations. Foundations form the final link in the load path by collecting the lateral forces from all stories and transmitting them to the ground. In the next video, you will learn about the considerations in structural design of tall buildings. Thanks for watching.